the limit as x approaches a from f of x is L, double equivalency, for every epsilon positive, I will find there exists a delta positive such that whenever I pick x close to a, this will always imply the distance between f of x and the limit less than epsilon. I hope you agree that no one wants to write this. The limit of f of x as x approaches a is L is equivalent to saying for every epsilon positive, I will find a delta positive such that when I pick x close to a, not equal to, so the distance is less than delta, this will guarantee that the distance between f of this x and this limit, L, will be less than epsilon. So before you think that this is difficult, let's work on an example. And then we'll look at numerical examples. So please give me a limit of a linear function, any linear function and any x approaching whatever you want. Any limit. Make up any limit you want. Linear function. Anyone, please?
For a function, a linear function?
Yes, any linear function you choose.
2x plus 3.
Very good. And where do we want x to go?
5.
5. What is the limit?
13.
Excellent. Brilliant. Very good. So this is equivalent to, for every epsilon positive, I will find the corresponding delta positive such that every time I pick x close to what? So that x minus, the distance between x minus something is less than delta. Can you identify here what I have to write? X minus what?
X minus 5.
Absolutely, right here. We know that. X minus 5 approaches 0. That's exactly it. This will always imply the function value at x minus the limit will always be less than epsilon. What is the function value for x? It's a silly question. I know it's a silly question. What do I write?
X minus 3, or 2x plus 3.
Very good. That's it. Great job. So number one, there are 2 steps. This step and this step. I'm only asking you to do one. I'll show you what you have to do for the second step. We always start here. Combine like terms. 2x minus 10 in absolute value less than epsilon. I start here and I want to get this. Get this somehow. What would you say I should do in parentheses, in absolute value? That's why factor and simplify should always be on your mind before you do anything else. So what can I do inside the absolute value?
You can make it 2 times x minus 5.
Brilliant. Thank you very much. Now be careful here. There is a property of the absolute value that we have to emphasize here. The absolute value of the product is the product of absolute values, You cannot remove this or put it in front. It doesn't work like that for absolute value. I have to write this at this step, which means the absolute value of 2, because it's a product, times the absolute value of x minus 5 less than epsilon. Only now I have to write that this is 2. And finally, remember, this is what I'm after. This is what I want. I have to have the absolute value of x minus 5 on the left. What should I do to both sides to get x minus 5 in absolute value on the left-hand side so I can compare? Less than, what do I do to both sides?
Take away 2.
Divide both sides by 2. So now at this point, I would like you to compare this to this and draw the conclusion how much is delta. And remember, delta must depend on epsilon. Delta cannot be 3 unless you tell me that epsilon is 6. Then delta will be 3. But that's huge, and we don't want that. So, how much is delta?
Epsilon over 2.
Brilliant. That's it. That's what it is by comparison. This is it. Now in step number 2, all I want you to write is show, because we have to show both directions, show that delta equals epsilon over 2 works by reversing the steps from above. Nothing else. You don't have to do the steps. Just write that, and that's good enough. Show that delta equals epsilon over 2 works by reversing the steps from above. Before we look at some numerical examples in the book, please make up another function so we can see this again. Or I will make up a function. Or I let you choose.
Could you read that part again? Show that epsilon over 2.
Yes, right here. Sorry. Epsilon over 2 works by reversing the steps from above. I'm not asking you for infinite limits. I'm not asking you for quadratic functions or any other function, just linear. I'm happy with linear. That's it. So please choose a linear function, and you can see what's the use of this. We're going to look at what the use of this is. So please choose a function from here, or any function from here that is linear. This is simplifiable, so that's why it's here. So we can use something with fractions, or you can use anything else. You choose, or you make one up. It's up to you. We just need to illustrate one more time, and then we'll look at a numerical example to see what's the use of this. I'm ready.
Number 18.
Number 18, very good. So I'm on page 10. We are looking at 18. 18, okay, limit. Okay, allow me to choose something more interesting, like a little bit, if you don't mind. 19. You'll see why. Because 18 and what we just did are the same. So 1 minus 1/3 x, let's put a little spice on it, equals -2. Okay. First of all, I want to make sure, let's say 9 divided by 3 is 3, 1 minus 3 is -2. That's correct. So now I want to write the definition. I have to write the definition always. For every epsilon I pick, positive, I will find the corresponding delta, positive, such that, when I pick x close to what, less than delta, I will always find that f of x minus the limit will be less than epsilon. What goes in here?
Professor, I'm lost.
I'm sorry?
I'm lost.
I'm only following this step by step. So the limit for every epsilon positive, there exists a delta positive such that when I pick x minus a, so x close to a less than delta, this will imply f of x minus the limit less than epsilon. So what goes in here?
Would that be 9?
Of course, it's x. Next, what goes in here?
Would that be 1 minus?
Yes,
1
the
over
function
3x?
value, 1 minus 1/3 x. What goes in here? It has to be the limit. And I have to put it in parentheses.
Oh, sorry.
The limit is
Negative.
this.
Okay, do not. X
So
equals
this is
negative
the L, this is the function, and this is the A. Good. So we start from the end. And we have 1 minus negative 2, which is positive 2. So 1 plus 2, this will be 3, minus 1/3 x, the absolute value, less than epsilon. Remember, this is what we are after. This is what we need. On the left-hand side, I need to have the absolute value of x minus 9. Not 9 minus the absolute value. I have to have the same thing. This is what we need. Okay, what would you recommend next inside here? This is just algebra now. What do I do with this? You
You can multiply by 3.
No, careful. You have to say find the least common denominator. We do not multiply Ly in absolute value ever. We do not multiply in absolute value. That's not allowed. So first we have to find the least common denominator. What do I have at the top?
Maybe 9
Minus
1x or just x.
Very good. Awesome. Now I have to factor out negative 1. So let's factor out negative 1 and let's see what do we get. Because it's not the same. What do we have in parentheses?
9 plus x.
We factor out negative 1. What do we have in parentheses?
Negative 9 plus x.
Very good. You mean, yes, or x
Sorry,
minus,
x.
you're right, you're right. Negative 9 plus x is fine, but I want to present it in the correct order. Negative 1 times x is negative x. Negative 1 times negative 5 is positive 9. Now we have negative 1 times this times over 3. We also have a over b in absolute value equals the absolute value of a over the absolute value of b. I have to use these properties that we just mentioned. The absolute value of negative 1 times the absolute value of x minus 9 times over the absolute value of 3 less than epsilon. How much is the absolute value of negative 1? Perfect. What is the absolute value of 3? Good. So then I have x minus 9 in absolute value over 3 less than epsilon. I'm after this. Now I know exactly what I need to do. What do I need to do to both sides to get the absolute value of x minus 9?
Multiply by 3.
Good. Awesome. So what do I get? Excellent. What do I get on this side?
Three epsilon.
Can anyone give us delta now?
It would be 3 epsilon.
3 epsilon. That's it. Delta depends on epsilon. It's a corresponding delta. And you know what you write as the second step. Show that delta equals 3 epsilon works by reversing the steps, blah, blah, blah. So step 2, show that delta equals 3 epsilon works by reversing the steps from above. How do we...
So I'm sorry, just to clarify, do we actually have to show that it works, or we just have to write that?
That's it, this sentence. I don't want you to do anything else. I just want you to write the sentence. The sentence tells me that you know that the double equivalency symbol says show from here, here, and then show from here, here. I don't want you to do it, to do the steps, no. Just say show that delta equals 3 epsilon works by reversing the steps from number 1. That's it. You're not required to perform any steps per se. Okay, one more question before we look at the numerical example. Do we need another one? Yes or no? Anyone? Okay, so let's look at the numerical example. What is this for? Why do we even talk about it? Well, it's basically if you know there is an error in X, it will trigger an error in Y, and vice versa. If there is a tiny error in Y, you know it will trigger an error in X. So that's the idea. So let's look at the numerical example. So use the given graph of f of x to find the number delta such that. So let me copy that. Do we feel better about this definition with these 3 examples or not? Still not. But once you're going to look at these, I mean, we can look at another example. Once you're going to read or, you know, just watch these, it will be very simple. They're just basically replacing A, L, and f of x in the definition. Just give it a little bit of time. So, see, obviously here the limit is 1. Can anyone identify epsilon in this graph? Looking at the graph, what would you say epsilon would be?
0.2.
Exactly. Because I have 1 plus 0.2 is 1.2 and 1 minus 0.2 is 0.8. Awesome. Good. Can anyone now look at what's happening around 1? How do I know? Well, because it's x minus 1 and it's f of x minus 1. So I know the limit must be 1. This is f of x. So it's very clear from this piece that epsilon is 0.2. F of x minus the limit in absolute value, the distance is 0.2, which we already knew from the graph. That's epsilon. They want us to determine delta. So tell me, what is this distance? And what is this distance? So one possibility for delta 1 is, and the other possibility for delta 2 is. So can anyone give us this distance?
0.1.
0.1. Very good. Can anyone give us this distance now?
0.3.
Yes. We have to choose the minimum of those two. So in mathematical terms, we write delta equals min, the minimum of 0.1 and 0.3. And what is the answer? 0.1. So again, the reason is that if I choose the smallest one, x will always fall x I pick, its f of x will always fall within epsilon away from 1. But if I choose the biggest one, look what happens. So I will get here, and it's completely outside. So we always choose the minimum of the two. That was a numerical example. Okay, here this is a different situation. Again, can anyone here tell us what is epsilon for number 3? You can determine it from here, or you can determine it from here. What is epsilon for number 3?